Example 9. The question is this: Selvi's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, an underground tank which is in the shape of a cuboid. The sump has dimensions 1.57 meter by 1.44 meter by 95 centimeter. The overhead tank has its radius 60 centimeter and height 95 centimeter. Find the height of the water left in the sump after the overhead tank has completely filled with water from the sump which had been full. Compare the capacity of the tank with that of the sump. So, overhead tank which is in the shape of a cylinder and its radius is given as 60 centimeter and height is given as 95 centimeter. And a tank, underground tank, it is in the shape of a cuboid. Here L, B and H are given, but here we should be very careful because some measurements are given in meter, some are given in centimeter. You have to make everything into same. So what I am going to do is I am going to convert everything into meter. So overhead tank has radius 60 centimeter. So 60 divided by 100 which is equal to 6 by 10 meter. So 0.6 meter. And what about the height? Height H is also equal to 95 by 100. So I am going to write this as, we have to use 3.14 because they had given to use pi as 3.14. So 3.14 into 0.6 into 0.6 into height is given as 95 by 100, that means 0.95 meter cube. This is the amount of water or volume of the cylinder which is the overhead tank, and what you have to find is how much water is in the cuboid, that means the sump, that means the underground tank. It is given as 1.57 into 1.44 into 0.95 meter cube. So what you have to find is, find the height of the water, find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump. So you have to find out the height of the water level, find the height of the water level left in the sump. So what we need is how much water is remaining in the sump. That means the water remains in the sump is clearly is equal to the volume of the cuboid minus volume of the cylinder, that means LBH minus pi r square h, which we can write as amount of water left in the tank, left in the cuboid, and the cuboid is equal to LBH minus pi r square, which is equal to 1.57 into 1.44 into 0.95 minus this, which is equal to actually we need to find the height of the water level. So amount of the water is actually this much amount is remaining there, but how can you find this? It is actually volume of the remaining, isn't it? Volume of the water, volume of the remaining water is equal to this much, that means 1.57 into 1.44 into 0.95 minus 3.14 into 0.6 into 0.6 into 0.95. So, what I am asking is, how can you find the amount of water? That is actually the volume. That the shape of that water is also in the cuboid shape. So, we can find the volume using LBH. So, we can find the volume, actually it is LBH. LBH I am writing here as base area into height, because see, the volume of the cuboid is LBH. Here LB is the base area and height. So, what you have to find here is, here we have to find H. So, we can use this formula also. Volume is also equal to base area into H. So, what is the volume of a cylinder? Pi r square H. Pi r square H. What is pi r square? It is the base area, isn't it? So, we can use base area into height. So, base area into height is equal to this. Same thing you have to write. Then you can find base. What do you mean by base area? L into B. H is equal to 1.57 into 1.44 into 0.95 minus 3.14 into 0.6 into 0.6 into 0.95 divided by L into B. It is the same as L and B of the cuboid itself, because that water, only the difference in the water level, that means difference in the height. Length and breadth are same. So, what we can write is L into B, 1.57 into 1.44. Using this you can find the height, and the last section is compare the capacity of the tank with that of the sump. You have to find the ratio of the tank and the volume of the sump, which is given in the textbook. You can go through that, you can complete this problem. Next one, example 11. Example 11 is a hemispherical tank. A hemispherical tank full of water is emptied by a pipe at the rate of 3/4/7 liters per second. How much is the time will take it to empty half the tank if it is 3 meter in diameter? We have to find the time taken to empty the half of the tank. So, what is given here? What is given here? Hemispherical tank. Radius is given as 3/2 meter. Volume is 2/3 pi r cube, which is 2/3 into 22/7 into 3/2 whole cube, which is equal to 99/14 meter cube. And what is given is the amount, the water is emptied by the pipe at the rate of 3/4/7 liters per second. So, clearly what we need is volume, and how much water to be emptied? Half of the volume. So, we can write this as half into 99/14, which is equal to 99/28 meter cube. But they are emptied at the rate of 3/4/7 liters per second. So, we have to find how much liters of water is in this. So, for that we have to use this relation. 1 meter cube is equal to 1000 liters. So, this much meter cube is equal to 99/28 into 1000 liters. So, what is given is 3/4/7 liters per second. What we have to find? How much time is needed to empty half of that? So, 3/4/7 liters means how much liters? You have to make it as improper fraction. So, amount of water emptied, amount of water emptied in 1 second is equal to 3/4/7. So, which is equal to 25 by 7 liters. So, what is the time taken to empty this much water? Therefore, time taken to empty how much water? 99,000 divided by 28 liters of water is equal to 99,000 divided by 28 whole divided by 25 by 7, which is equal to 99,000 divided by 28 into 7 by 25, which is equal to 16.5 minutes, 16.5 minutes, which you can find. This is also example question. Next is exercise 13.3, third question. The question is, water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeter of standing water is needed? Actually, canal and field we are considering as cuboids. Canal is a cuboid and field is also a cuboid in the shape of a cuboid. So, water in the canal and what is given is 6 meter wide. That means breadth is equal to 6 meter. Breadth is equal to 6 meter and height is equal to 1.5 meter. What we need is how much area will irrigate in 30 minutes. What we need is 30 minutes. What is given is the speed of the water is given as 10 km per hour. That means 1 hour 10 km. So, distance covered in 1 hour is 10 minutes. What we need is 30 minutes. Distance covered in 30 minutes is 5,000 meter. It is 10 kilometers. So, converting as meter, then half of that, that is 5,000 meter. So, and field, what about the field? Field is, height is given as 8 centimeter, that means 8 by 100. What we have to find is how much area will irrigate. How much area will irrigate in this? That means we have to use the volume as base area into height. So, what we can use here is volume of the canal is equal to volume of the field. Volume of the canal is equal to volume of the field. So, what we are using is L1 B1 H1 is equal to base area into the height H2. What you have to find is how much area, base area we have to find. Here we can use, actually this is the length. We are using this as the length. So, base area is, base is 6 meter, height is 1.5 meter and length is 5,000 meter. So, we are writing it as 5,000 into 6 into 1.5 is equal to base area into 8 by 100. From here you have to find the base area. Base area is equal to 5,000 into 6 into 1.5 into 100 divided by 8, which you can find. You can find the final answer. Next, ninth question. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at the rate of 3 km per hour, in how much time will the tank be filled? So, pipe and cylindrical tank. Pipe is also a cylinder. So, here what is given is R is equal to 10 centimeter, which we have converted as 1 by 10 meter, and height is given as 3 km, that means 3000 meter, and cylindrical tank radius is given, height is given. So, what you have to find is how much time taken to fill the tank. So, what you have to take is, let x hours be the time taken. So, x into volume of the pipe will give volume of the cylinder. X into volume of the pipe will give volume of the cylinder. So, what is the shape of the pipe? Pi r square h itself. So, x into pi r1 square h1 is equal to pi r2 square h2. Pi and pi we can cancel. So, we have to find x. X into R1 is 1 by 10 into 1 by 10 into H1 is 3000 is equal to R2 and H2. R2 is 5 into 5 into 2. From here you can find the value of x. You can find x as 5 into 5 into 2 divided by 3000 into 10 into 10. You can find the answer later as homework.